Okay, let's take a look at a problem with a two-proportion z-test. We have 200 female students. 80 say they would rather have an early morning class than an evening. Of 200 males, 80 say they would rather have an early morning class than an evening. And then we want to know if females are more likely than males to prefer an early morning class rather than an evening class. So the first thing we're going to do is just create a table out of these data. So I have a table I'm going to call morning, and I'm going to assign that matrix. You can either use an equal sign or a less than with a minus after it. And so I'm going to say in this matrix, I'm going to combine 88, that's the 88 females, and then 100 females who did not prefer the early class, then 80 and 120. That 120 and that 112 are again just 200 minus 88 and 200 minus 80. And I'm going to say I have two columns and I'm going to go by row. So the row names are going to be female and male. So I'm going to have in the first row 88 females who were early and 120 females who like the late or don't like the early class. And in the second row, I'm going to have the 80 males that say they'll like the early morning class and the 120 who do not say that. And then two columns, early and late. So the 88 and the 80 are going to be in the column with early, and then the 112 and 120 in the column with late. And then I'm going to tell it to just save all of that as a table and then print it. So I'm just going to highlight all of that. And now I have a table with early and late, female and male. So I've just used this problem and put the data in like this. For your assignments, if you're in my class, probably just want to revise this and give it names that make sense, and of course numbers that fit the problem that you're working on. So the next thing we want to do is a bar plot. So I'm going to do a bar plot of this table called morning, and I'm going to put beside equal true just so I don't have stacked bars, which is the default. And so there we have that. And I'm not going to put all the text on there, but I'd like to have it say where I have male and female in here. And so I'm going to put female right about here at 1.5, which is the middle of the first box. So I'll center that, and I'm going to put it at 92, which is somewhere in here. And of course, you should go ahead and do that for each box and then add a title and that kind of thing, but I just wanted to get you started on that. Then I'm going to do a prop test on the table morning, and this is a one-tailed test, so I should make this alternative equal greater. And there we go. And you can see now that I have a p-value of 0.2391, and then there's a chi-square value. Now the z-value is just going to be the square root of that. So in this next row, I put z is equal to square root of whatever the value I have there for chi-squared. And if I could put the z on a separate row, but instead I just put colon and z. So I've got that there. So I'll compare that 0.71 about to whatever the z-test value is in your test. If this were 0.05, you would reject HO if z-test is greater than 1.645. Since this isn't, you would fail to reject HO. We're also going to go ahead and do an effect measure for the two proportion z-test. And it's in a package called Psych, so you may have to install that. Just go over to your packages and hit install and type the name of the package you want to install. Psych. I've already have mine, so I don't need to do that. That's to put it into your list of packages that you can use on your computer in the future. But even once you have those, you have to load them into memory to use them in this particular run. So I'm going to require that package. And then Phi stands for the Phi coefficient. And this is actually a correlational measure. So instead of comparing to 0.2, 0.5, and 0.8 like we did with the difference measures, for correlation measures, we'll use 0.1. Anything less than 0.1 will be trivial. Then once it gets to 0.1, we'll call it a small effect. Once it gets to 0.3, a medium effect. And once it gets to 0.5, we'll call it a large effect. And I'm going to go ahead and put in here digits equal to, just to keep that from carrying out a bunch of places. And there we have a very small, trivial effect size. And it's not statistically significant anyway, but anyway, that's how to get the Phi coefficient. Or Phi. I think it's Phi, but who knows? Phi, Phi, Fo, Fum. That'll be it for this lesson.